Horizontal asymptote for rational function. Now before solving this question, let's understand what horizontal asymptote is. So when we are trying to figure out what horizontal asymptote is for a given function, we are basically trying to find that if x approaches infinity, what happens to f of x. So if f of x approaches a fixed value, then we say that the horizontal asymptote exists, and the equation of the horizontal asymptote will be y equals to L, the value which the function is approaching. Now this is when x is approaching positive infinity. Horizontal asymptote is also considered when x is approaching negative infinity. Then also we have to check what value the function is approaching. Is it approaching some fixed value? Let's say L again. I'm just taking L as a variable, right? These two L's could be different. Then again the equation will be y equals to L, the horizontal line which the function is approaching. So that is what we're trying to figure out. Now when we do curve sketching, there's another very important criteria, and that is to see whether we are approaching this fixed value from above or from below. So that is another thing which we should be checking on, right? Now any rational function can give us three conditions. One is when degrees of both numerator and denominator is same, like the one we have here, and then we could have a rational function where degree of numerator is higher, or third case could be degree of denominator is higher, right? So there are basically three cases. So we'll consider all the three cases one by one. So in this video we have a case where degree of numerator and denominator is just 1 and they are absolutely same, correct? So how to solve such a question? So what we need to find here is limit of the function as x approaches, let's say, positive infinity. So we'll do for positive infinity, and method for negative infinity is exactly same. And the function for us is 2x plus 1 over 3x plus 2. Now we can write this as equal to limit x approaches infinity, and let me factor out x from here in the numerator. What do we get? Get x, and within bracket we get 2 plus 1 over x, right? And in the denominator we can again factor out x, and we get 3 plus 2 over x. Now you can see if x is a very high number, x approaching infinity, right, then these two numbers will approach 0, right? So we'll have 2 plus 0 and 3 plus 0 in these brackets, correct? And now x and x is common in numerator and denominator, we can cancel it out. So we can simplify this at this stage and say this is kind of equal to limit of the function where x approaches infinity is equal to 2 over 3. Now this is the case where if x is approaching infinity, 1 over x is very small, correct? It is approaching 0, and 2 over x is also approaching 0, correct? And therefore we can write this as limit of function where it is approaching 2 over 3. Now this is a constant. This constant will approach a value only, which is 2 over 3. So in this particular case, what you notice is that if the degrees of numerator and denominator is same, then that x to the power of that can be factored out. And once you factor that out, whatever you get in the brackets will be a constant plus some ratios in which x is in the denominator. As x approaching high value, 1 over x will approach 0, or 2 over x will approach 0, correct? So this could be simplified as limit where x approaches infinity for a constant 2 over 3. As you can see, now our function, which was 2x plus 1 divided by 3x plus 2, as x approaches infinity, approaches a constant value 2 over 3. And therefore we can now say that there is a horizontal asymptote, and the equation of the horizontal asymptote is y equals to 2 over 3. right? So that is how we get equation of the horizontal asymptote. You will notice in this case that always you will get the answer as the ratio of leading coefficients, 2/3. So the ratio of leading coefficient is the equation of horizontal asymptote when the degree of denominator and numerator is exactly same. So this you can generalize. Now you can do the same process for x approaching minus infinity, right? So if I replace this with minus infinity, let us say we do it right here without making much change, exactly the same process, but this time with minus infinity, approaching minus infinity. Even then, 1 over x, if x is approaching minus infinity, will be 0, correct? So what I'm trying to say is that limit of, let's say, any parameter k over x, where x approaches plus or minus infinity, is what? Is actually 0, right? If x is very large, then k over x is approaching 0. It is, I should say, approaching 0, right? So these factors will become 0 when we are approaching plus or minus infinity. So what really remains is the ratio of leading coefficients, and therefore the leading coefficient ratio will be the horizontal asymptote for such cases. I hope by generalizing you have understood that we can solve each and every problem of rational function and get to the same result. Thank you.